We got Silas online already. Hello, hello. Are you there?
Hey,
there he is.
Can you hear me?
Yeah, we can hear you.
All right, great.
So yeah, this can be good. So another automotive use case. So Silas Toms from Volta Charging, going to tell us about using PostGIS and machine learning. Not just PostGIS, machine learning, to predict electricity demand growth for or from electric vehicles. Thanks for coming to talk with us, Silas. I'm going to hand it over to you.
My pleasure. All right, you can see that?
Yes, we can.
All right, let me go back. Sorry, I'm not at the beginning. My apologies. Well, thank you again, Paul and Elizabeth and the team for having me. I love PostGIS Day. It's really fun to be involved today as a speaker, but I've been loving PostGIS for 12 odd years now, championing it. And I know I'm late to the game as far as you guys go, but it's really, really cool to be able to use it every day now. And team I'm with now is Volta Charging, which we just went public earlier this summer, and we do free electric charging. It's a interesting space to be in right now, because while I think 1% of cars are electric sales, that is, are electric cars in the United States, they're mandated by, I don't know, 2035 to be 100%, at least in California and other states, and there's some federal mandates as well. So we're seeing the future happen, and we're sort of predicting it now. And what we do is free electric vehicle charging for the general public. You'll see our stations in front of malls and like Whole Foods and other different public locations where we can both allow electric vehicle owners to charge their cars for free for an hour or two. And then we also have ads on the stations that support the free charging. So that allows us to give away the electricity by charging the advertisers. Most of our stations now are level 2 stations, which means they're top-off stations. They are slow chargers that will just give you, a 10% or so over an hour. You may have seen like the station on the right out in the public in different places. We've gone, I think we're at our 3rd iteration of stations now, where we have more dynamic advertising, and we will have a whole lot more there as well. And then we have an app that allows you to find stations and interact and be able to direct your car towards it when you're on lunch or whatever, and you need to charge up your electric vehicle. We also do some like kind of odd wall mount chargers you'll see in garages and such. There'll be more and more of these in the future. We're already pretty well spread out, as you can see here, across the country. And we plan on just expanding more and more over the next few years. So I think, with the growth of EVs, you're just going to need a growth of infrastructure. And what we are using PostGIS for is the ability to both internally and with our external utility clients, help them predict where to both put charging stations that will best help people throughout their daily day-to-day, and also for utilities to be able to predict what kind of load the electric vehicle growth will bring to their infrastructure, and therefore what kind of capital expenditure they need to plan for the next 10, 20, 30, 40 years as they plan out and start to decide how many power stations they need to build, what kind of substations they need, what kind of distribution grid they need. And that has a lot to do with, predicting growth in EVs. And so Predict EV allows them to enter in scenarios, different custom scenarios, based on census data, POI data, visitation data, to say like how many people will visit this particular block group or neighborhood, or you could do custom polygons as well through the application to say like within this area, given this potential demographics and people who would probably buy EVs, what is the potential for electric, utility use over, whatever time period you're interested in. So we try, we have a focus on 20-year time horizon for now, but you can choose lesser amounts of time. And we not only predict, like, for internal use, the impressions that people will look at these screens, but the kind of what they call load shapes, the amount of electricity required to support throughout a day, throughout a month, throughout the year, the use of EVs in a particular region, very specific region. So geography is obviously incredibly important here. Now, these predictions are based on machine learning. We use a lot of TensorFlow, and we take, like, the current state of vehicle registration data and demographics and predict very specific, down to the block group level, what kind of growth we expect to see, and therefore what kind of growth you should expect to see in electric consumption. This allows us to communicate, with the major players within the electric environment, especially utilities. Like, we work with a lot of southern utilities as they're seeing the need to plan for capital expenditures, and therefore to decide, like, what kind of growth they should expect within their state or their territory, down to a very specific level, because that's the kind of specificity they require to plan for the future. So the Predict EV application is a software as a service application that's web-based, and it's built on this technical infrastructure here. PostGIS is our database of choice. It powers, all of the data storage, as well as a whole lot of data queries. We use it to do, we do a lot of relationships between demographics data at the block group level, and predicting, like, how many stations are going to be required in the next few years to service the growth we predict there. We use Django behind the scenes to power these queries from the front end, which is a React front end, and use a whole lot of ST as GeoJSON to return the data and display it. PostGIS, makes this possible. Basically, it's cloud-based PostGIS that we, power few different versions of the Predict EV, both internally and externally, and it's also called by the ML to do our modeling as well. So for the PostGIS backend specifically, it's both regular database queries as well as the spatial database engine. We do a whole lot of, you can draw within the application, which I'll demonstrate here in a minute, the potential area of interest that you'd like to query data on. And this, by generating that in the front end and then sending it as coordinates to the back end, you can then send it against the block groups that we store most data at. We do accumulate up to all kinds of different levels. We have, cities and zip codes and urban areas and anything that the census data provides, and then ZTCAs, which are sort of semi-census. But it really depends on a lot of custom queries too, to be able to intersect between the areas of coverage by each power company and the demographics from the census in that area. For getting the data into the database, we use a lot of SQL Alchemy, which is a very powerful Python module that allows you to write models of database tables and either generate a database or use existing database tables and write to it. And then to make the spatial data available through SQL Alchemy, which it doesn't include initially, we use GeoAlchemy 2, which is very powerful add-on that adds a geometry column to the SQL Alchemy module, and it allows us to then read from all kinds of different data sources, because we get data from CSVs or shapefiles or even GeoJSON, read it in and then convert it into well-known text and write it into PostGIS. Most of this is done on AWS RDS, which makes PostGIS available, which is super nice. But we also do some AWS EC2 hosted servers that allow us to test data as well and not incur some of the costs that RDS has. Like RDS is very available and constantly updating it, but it's not cheap. So we have a mixture of different versions of PostGIS that allow us to test new data and add it then to our main database for the application. So one of our main clients is Alabama Power in the South, and we've worked with them to really develop the tools that they need to be able to say, what kind of people, age ranges, household income and such are we serving down to the block group level. Now we chose the block group level because at the block level, the census block level, not a lot of data is available. There's a whole lot of population data, but it doesn't really include income or other super important data sets. So we had to go at the block group level, which if you don't know census data, it's about the size of a neighborhood, which is pretty good. Alabama Power wanted to know, what kind of demographics are within the area that they serve, which is central and southern Alabama. And I have to say the southern states have been very forward thinking on this as they plan for their next X amount of years servicing their customers. Even though we think of the growth of EVs as kind of like a California thing or a New York thing or something, it's coming everywhere. So I think the smart utilities are grasping onto that and making it so that they can service these their clients, even though it's a small group now. It won't be in 10 years. So let me switch over here. So here is one version of the application itself. Turn off this. We can zoom out here. And you can see it's quite fast to load the data here. If I turn on the block groups data for the whole United States, you get whole coverage of the United States. And then the cities are also available. We do planning along road corridors as well. So we have most major freeways in the United States and smaller state highways, because we want to be able to say what kind of infrastructure will be required to support, the common travel, like road travel in the summer or whenever. And, EVs are going to need to have both level 2 to top off as they drive around during the day, but then as we'll get into, they'll need DC fast charging, which is the next level, the next phase. Sort of, if you think of the Tesla supercharger network, they are a series of DC chargers that much faster at charging. You get to about 80% charge in your electric vehicle in 30 minutes or so, and that's kind of the gold standard for charging up and getting somewhere fast. And fast, I guess, is relative. There's going to be other solutions that people will think of, maybe swapping batteries at these stations or something, but for now a major portion of the charging will be DC fast charging, and that's part of our future plans as well. As a advertising company, we also really care about, marketing areas. So we include the Nielsen demographic marketing areas here. We also have zip code data to aggregate to. But if you say actually go to a city here, and you can click on a city. Let me zoom into one. We include all kinds of data through the application. So we have different kinds of verticals, different malls or golf courses or other kinds of locations where we might want to put stations. We include the potential media metrics to say how many people would probably see ads in this area, and per day, per week, per year. We include crucial information on the breakdown of the audience. What's the population like, female and male? What's the median age? What's the breakdown in age in terms of 1 to 17 all the way up to 85 plus? Obviously census data is a huge part of our operation here. And then how many households are there? Are they considered urban or rural? Ooh, sorry, let me log back in. Just one sec here. And with PostGIS powering this, we can aggregate the data at different levels. So we can do the city data. So I've clicked on a city here. This is the city of Chicago, obviously. And then it queries against all the block groups within that area. For a bigger city, it might take a while. You can see this bar going up here, but it allows us to publish data for any kind of different geometry of interest. Go to a smaller city, maybe. Here we go. So this has become a super crucial part of our day-to-day workflow to both, this version we're looking at here is more for deciding where do we place new stations. And there's a relationship there too with like the supermarkets that we have established networks with, and then where some municipalities are more open to charging versus like maybe I would call them more closed-minded municipalities. It's not just as easy as just using the data and saying, all right, this is where we're going to put them. There's a reality of getting things on the ground. However, the data helps a lot. It makes it very crucial decisions for us, and allows us to use the power of ML and GIS to say, all right, this is definitely what we want to target. Then you can also put in existing charging stations here to see, non-Volta ones, maybe like where's public charging stations. You can see what we consider the EV adoption in the area based on vehicle registration data. And then you can create a custom scenario up here to be able to say what the growth will be. So this gives you a vision of data now, and then if you go through it, you can see in the future. Come back to my presentation here. So for next steps, we are working on a couple of different growth avenues for PredictEV. We're going to work with fleet owners to say, what kind of fleets do you support? Usually they're internal combustion. So how can we identify tools, new cars, the specific types of cars that will replace the internal combustion cars that you rely on? And how can we support your charging needs as you move throughout a region, delivering, boxes or whatever this fleet might happen to do? We're going to do a whole lot of station and location analysis to figure out where the stations should be placed and how to smartly get them in front of people. Because as I said, we are an advertising company as well. You can kind of think of it as like a real world Google in some ways, that gives away, Google gives away search, makes money on advertising, and we give away electricity and make money on advertising. And then for utilities, we're going to work with them to say, what kind of demand should you expect? What kind of load shapes will you expect? That is like, what kind of strain will the growth in EVs put on your grid? And then last but not least, what are the environmental concerns to consider? We want to consider, like, how can we show that air pollution will be directly affected by the growth of EVs? The reduction in air pollution is a big deal, especially in concentrated cities where there's a whole lot of particulate matter and cancer risk. So this is just the base team. We've been working on this for over 2 years. I give most of the credit to Anna Bailey, the product manager, who had this vision, and Praveen Mandal, who gave her the power to do this. He's very visionary. And then he brought in David and I. We were contractors working on this before we got hired full-time at Volta. And it's been very interesting, and doing what I think is shaping the future of cars, of transit, of cities, figuring out how can we predict what people's mobility needs will be and how to support it through EV charging. So that's it for my presentation today, and I'm hoping you'll have questions. Let's see here.
Well, I've got a couple, and
Sure.
hopefully other folks will hop in with theirs. So I guess first question is just around the core business model. You can give me some idea. Like I've seen, I remember a fellow who was like in this business back when it was a new thing, a new idea, the idea of little ads on gas pumps, right?
Yeah.
Oh, we'll put ads on the gas pumps. It'll be great. Like, that sounds really silly, but
Yeah.
it did, and it kind of worked. So, okay. So ads on chargers is not a big leap from that, but I guess the difference is, you are literally giving away electricity. So is attention really that monetizable, and electricity that cheap?
Yeah.
Well,
yeah, it is. Yes. Advertising is, incredibly important business. It powers, television, powers Google, which is just billions and millions of dollars. And now it powers us. It is very much a something that can power a business like this. We're also moving into charging for charging, as they say, with the DC fast charging. So that we won't give away for free. It will be, a similar setup of stations, but we'll probably have parks kind of like the supercharger network, and allow people to charge much faster for a premium.
Okay, I got a question from David Halema. Are you facing any use cases that are difficult to address with your current tech stack?
I don't think so. It comes like, I think we're using top of the line tools with PostGIS and Python and a whole lot of ML modules within Python. It comes down to understanding what the data can do and what the data can't do as far as like putting in stations. There's a whole lot of human relationships that are involved with negotiating the actual installation of hardware in the built environment. So that's, an impressive job that I think Volta has done already before we came, to be able to establish relationships with, Whole Foods or other big companies, and then also get all the permitting done. There's a whole lot of permitting work that has to happen. So I think that the tech stack itself has been great. PostGIS is fast and reliable and does all the queries, which aren't heavy queries per se, but it is, obviously a whole lot of storage. And then well, there's a lot of internal stuff we're using for as far as data engineering.
Right.
But for this application, it's been great.
Awesome. From James Smith, wondering if you adapt and allow charging of electric bicycles also. I guess not huge in the US, but becoming big in the EU.
Well, yeah, I had that thought as well. And I think there's something to that. It is, we are potentially, we do want to expand beyond the United States. There's still a lot of things to determine there, but it's a very good point. We should support non-cars and transit solutions. And we don't have to just support cars with our stations for any reason other than like that's what we've been targeting so far, because again the main source of revenue is advertising. So wherever we can put it, it will help support people, and people could be on a bike, they don't necessarily have to be in a car.
Josh Clark is asking, do you have a consumer facing app or thoughts on integration with auto manufacturers?
Well, we do have a consumer-facing app that allows people to find stations and create an account so that they can charge when they get to the station. And there'll be more growth there. I think that is available, downloadable on your phone. And I think we'll see new innovations there as well. So it'll kind of help you eventually like plan your day throughout your movement throughout a city. The truth is most travel is like within 20 miles of your home, probably less really for day to day. So EVs we're still getting used to EVs. And a big part of it is like just the comfort with finding a station and being able to plug in. We provide a lot of that comfort to people, but we also want to go further and help them plan their day as far as how they travel throughout the built environment and owning an EV car.
Got a question from Ganesh. Are you able to iterate on your stack fast enough to keep pace with the competition? For example, Tesla, ChargePoint.
Well, we're not in competition with Tesla per se, because Tesla is a car manufacturer. Mm-hmm. We don't. We do provide like charging to Tesla cars, but Tesla superchargers only charge Tesla cars. They don't charge other EV cars. So in that sense, they're sort of a closed market. But we, a Tesla driver can plug into our stations now and top off, get 10% in an hour or so. It's not really a competition per se around that, so much as it is. There's just a lot of growth. As I said at the beginning, cars are like EV cars are 1% of sales in America. So to get to 100%, that means there'll just have to be an incredible shift in how the relationship is with the road. And I see John's question here around that. You gonna read that one?
Yeah. So John Hickok asks, city, county, and state governments are funded by gas taxes. How will road maintenance be funded?
And I don't know if I have the answer to that. That's a much bigger question, than around how we've decided to fund cities and road maintenance in general. I think that there's a whole lot of need to change how we, I guess, address funding. With the gas tax itself, it probably needs to be increased anyway. Mm-hmm. But how it relates to EVs is a big deal. Now, the truth is, like most damage to roads comes from like large trucks, but those will probably be EV as well soon enough. So it's a bigger question. I don't think we have the answer to that as a company, but I'm interested in working on it.
So I think I'm gonna close it off here now and ask if you wouldn't mind hanging out and answering any other questions that show up in the chat or in the Q&A.